given the expression on the left hand side equals the expression on the right hand side. We have to prove that those two expressions are the same with the condition that phi equals tan inverse of -3 on 4. So first, to easily solve this, we need to express this condition, the condition given to us, phi equals tan inverse of -3 on 4 on the Cartesian plane. So now, since the tan inverse is negative, okay, so meaning the angle gives us a negative ratio, so that means that it either falls on the second quadrant or the fourth quadrant, the last one. So I will use the second quadrant for it. So we have here phi here, and this is tan inverse, so there will be opposite on adjacent, because tan ratio is given by 2, so you have opposite on adjacent. So we have here 3 and 4 here. So when we solve this using the Pythagoras approach, we'll be having hypotenuse to be 5. So here becomes 5. With this, we can conclude that sine of phi will be equals to 3 on 5, and cos phi will be equals to, as for 4 on 5. 4 on 5. Now we need to note that the angle, the tan inverse, is of a ratio of a negative value, so meaning the tan of the angle gives us a negative ratio. So because it gives us a negative ratio and we are using an acute angle, we need to make the acute angle a negative, so we make it a negative. And if you make the acute angle a negative, we note that cos is always cos is an even ratio. It's an even trig ratio. So for every cos of a negative acute angle, you'll be getting positive values. So that means that our sine will be negative. So it means that the actual diagram for this will be on this quadrant or in this quadrant. So it will be in the fourth quadrant, because sine is negative here but cos is positive. Okay, so with that in mind, bear in mind this. From here we create an expression, okay, an expression in terms of 4 and 3. So we create an expression for 4 and 3. So we make the 4 the subject in cos here, and we make 3 the subject in sine here, in sine ratio here. So from here we'll be making 3 the subject. We first decide to forget the negative, so we'll have 3 will be equals to sine of -5. Okay, so that will be equation 1. We do the same thing for the second one as well. So we'll be having 5 here. This will be the 5. Okay, 5 multiply here, so we multiply both sides by 5. So we have this. Here to the same thing. So we have 5 cos of -5. So that will give us an equation 2. So we substitute this into the mean expression here, mean expression on the left hand side here. So we'll be having, this implies that instead of 4, we put this. Okay, so we have 5 cos negative phi, then cos alpha t, plus, instead of 3 we put that, so we have 5 sine negative phi sine alpha t. Okay, so we can factorize this, okay, so that we can better simplify. So we're having 5 out, a bigger bracket, then cos of negative angle will give us positive value, since we know that cos of a negative acute will be, it's even, always even, cos is even, so cos of phi, then cos of alpha t, the same thing here, but we have already factorized the 5, so, but this is not even, this is odd, so we have sine is odd, so minus sine of theta, sorry, it's of phi, so we have then sine of alpha t, then we close. Now looking closely at this takes us to the cos identity, so we have the double angle identity, okay, double angle identity, or we can say the addition of angles. Okay, so we have here 5 bracket open, since it's cos and sine here, so we have cos of alpha bracket open alpha t, okay, then cos of plus I'm applying the identity straight away. So the first angle, okay, we use this angle, since you can interchange, so it doesn't matter, I want you to satisfy this here, so we have 5 cos of alpha t plus then the other angle, which is phi, then all should be in brackets, so we have this, so better simplify it, you have 5 cos bracket open alpha t plus phi, so we have this, and that is that. Let's solve. Conversely, we may decide to do it the other way around, meaning you may decide to use the right hand side as well to get this one. So conversely, you can have conversely, okay, or alternatively, so you have, for here, what you have to do is just expand this, the bracket, what you have in the bracket here, okay, so you'll be having, maintain this, so you have 5, then we expand this by the identity, so cos of alpha t, then cos phi minus sine alpha t sine then phi, okay, so all in brackets. Now we go back to the condition given to us here, okay, so we use the expression here, so we already know we have sine phi, so we have this and that, okay, so sine phi, which we already have it here, but here we say it's negative, okay, the angle is negative, so we can substitute this into this back, so we can write this implies that 5 bracket open cos of alpha t, then here cos of negative phi minus so it becomes plus. So you have sine alpha t, then sine of negative phi. Okay, so now we do the substitution. So we substitute this into this. So sine negative of phi into this and cos negative of phi into this as well. So we have in 5 bracket open. So cos of negative phi will be 4 on 5. So cos alpha t plus the same thing here as well. So we have 3. Yes, there's no need to use the 5 to put the negative again. So we cancel the negative because we have already applied the negative here. So if you are to use the negative sine of negative theta, okay, and maintain the negative here, so you have negative times negative, you get positive. So I've already applied it. So we have now sine alpha t. When you open the bracket, you get 4 cos alpha t plus 3 sine alpha t, and that satisfies this. Thank you.